Hello, welcome to this week's problem of the week. For this problem, we're trying to figure out how many 8-digit numbers exist such that they are divisible by 9 and have distinct digits. So the first thing we're going to do is we're going to look at the sum of all the digits 0, 1, 2, all the way up to 9. So we find that summing all the digits up, we get 45. And since 45 is divisible by 9, any number that has all 10 digits will be divisible by 9. And there are 10 total digits. So for an 8-digit number with distinct digits that is divisible by 9, the 2 digits that we don't use will have to sum up to 9 because, since 45 is divisible by 9, we'll need to subtract 9 total to have another number divisible by 9. So we have 10 digits total, 0 through 9. And out of these 10, we can find 5 pairs of digits whose sum is 9, 0 and 9, 1 and 8, 2 and 7, 3 and 6, and 4 and 5. So now, when we count the number of 8-digit integers that satisfy the conditions above, we're going to organize it into 2 cases. The first case will be 8-digit numbers that don't contain 0 or 9, and then the second case will include second case will account for the 4 other remaining pairs. So for the first case, we exclude 0 and 9. We are left with 8 positive digits. And so since we're using 8 digits for an 8-integer number, the number of possible numbers you can make is equal to 8 factorial. So for the remaining case, we are left with 8 integers no matter which pair we exclude. But for each of these pairs, 0 will be one of the digits in the number. So we have to account for that by saying that for the first possible spot, instead of having 8 possibilities as the leading integer, or leading digit, we only have 7 because if 0 is leading digit, then wouldn't be 8 integer number. So we will write that down. But then after accounting for the fact that we can only have 7 leading, we will have 7 factorial possibilities for the remaining 7 integers, since 0 can go in any other spot. So with this knowledge in mind, we know that there will be 7 times 7 factorial ways to create an 8-digit number. But now we also account for the fact that there are 4 pairs that don't have 0 in it. So we'll multiply this answer by 4. So now all we have to do is add up the 2 cases. In the bottom case, we have 28 times 7 factorial ways, or 28 times 7 factorial numbers, And in case 1, we have 8 factorial numbers, and we can rewrite 8 factorial as 8 times 7 factorial to make it easier to do multiplication. So all you have to do left is just add them up and see what the number is. And you see that for case 1, we have 8 times 7 factorial, which is equal to 8 factorial. We're adding that to 28 times 7 factorial, which was what we got in case 2. And that's equal to 36 times 7 factorial, which, if multiplied out, results in the number 181,440 8-digit numbers with distinct digits that are divisible by 9. Thank you so much for watching this week's Problem of the Week. Be sure to subscribe to our YouTube channel, follow us on Facebook and Twitter, and check out our website, centerofmath.org. Thank you.